the Centre for Sports Engineering Research at Sheffield Hallam University, they are helping some of the UK's biggest sports stars improve their performance. The team combine innovative science and engineering techniques, such as state-of-the-art motion capture systems and high-speed cameras, to track and analyse the athletes' every movement to help them be at the very top of their game.
Here at Sheffield we have motion capture systems to look at the biomechanics of the athlete. Generally you've got multiple cameras. In our case we've got 12 cameras with infrared sensors on them, and what they do is they track markers that are placed on the athletes, these passive reflective markers. Because we can track those in 3 dimensions, we can track the 3-dimensional motion of that person, and then we can start to look at the effective equipment or shoes or clothing or even individual interventions, strength and conditioning kind of things for the particular athlete we're looking at.
So now we're just going to carry on attaching some of these retroreflective markers to the body. We use these markers just to identify various anatomical landmarks or joint centres and just any points of interest. And then the red light that's being emitted from the cameras will reflect off these markers and is detected by the cameras, and then that's used to reconstruct the 3D model.
The motion capture system will then produce a 3D anatomical image of the athlete. Under the mat are load cells. When an athlete steps on these, it will generate a force vector. The greater the force, the longer the line will be.
So the foot comes down and you can see the force vector shooting up, and he brings his foot through and the ball shoots off. Now if we swing round to the back and rewind that kick, what we'll be able to see, we'll be able to see exactly the angle of that force vector when he kicks it. So here we go again. So you can see this force vector here is really highly angled. Now if that player wasn't wearing the right set of shoes on that particular surface, he's likely to slide and fall over. So what we can do is we can recommend particular shoes for particular surfaces, and that's the kind of thing we do for football boot manufacturers. Equally, the manufacturers of sports surfaces, whether they're artificial or whether they're turf, they can look at the best surfaces for football players to play on.
This system can also be used to detect sports equipment, such as a tennis racket or a golf club.
So what we have here is we've got our golfer in our 3-dimensional volume. You can see the point here on the end of the golf club, so that represents the golf club. Now what we can do is we can look at the swing of that golf club, and we can use that to enhance the performance of the particular athlete, or we can use it to perhaps redesign the golf club and help golf club manufacturers make better golf clubs. If we look at the forces here, we can look at the reactions of the player with the surface, and we can use that to make the golf shoes better, or maybe make some interventions with that particular golfer on his stance.
This information can also play an important role in assisting medical science and rehabilitating injured athletes.
So quite often what you see is you might see some inconsistencies, things you don't expect about the athlete, or in this case the golfer. Maybe some asymmetries, something not quite right.
High motion cameras recording at thousands of frames per second are also used to help analyse an athlete's body position and help correct any technical flaws which may be contributing to injury.
And quite often what you see is you see those same asymmetries in those kind of tests. Then what we can do is we can recommend some interventions. It might be particular routines with weights, particular fitness exercises to strengthen up particular parts of that person's body, and that gets them over any injury they might have had.